Welcome everyone. We are on the topic set theory, relation and function. So we just started the term set theory. So set theory is the study or the theories behind on the term set. So we just heard about what we mean by set, and our topic set theory is divided into some subtopics. So we also heard about its definition and some examples and some operations or some algebraic operations on the sets and the properties of that operations. Okay, so this is the subdivision of on the topic set theory. So we heard the formal definition. So what is definition of a set? So a set is a well-defined collection of distinct elements. So a well-defined collection of distinct elements is called a set. So we have a definition for a set, or we define a set in some way, and we say that definition or the thing in which we defined the set is well defined when, if we take any other object, then we can surely we can say that either that member belongs to that set or in the set or not belongs to set or outside the set. So that is the term well defined indicates, right? So a set means a well defined collection of distinct objects. So set has some objects and each element is distinct, and it is well defined. Means if we take any other object, then we can say that either that member belongs to our set or not belongs to our set. So that is called set. So it is a collection and it contains distinct elements and it is well defined. So a set is a well defined collection of distinct objects. Okay, so if you define a set, then that set can be represented mainly in two forms. First is roster form and the second is set builder form. First is roster form or set builder form. Okay, so that is the representation of a set. So we define a set as in some languages, then we can represent, we can write that set mathematically in two forms. So first form is roster form and the second form is set builder form. So in roster form, so anyway the set is a collection. So it's a collection of members or a collection of objects or a collection of elements. Then in the roster form, we listed each member or each elements in the set inside a bracket, right? Inside a bracket. So in an open bracket and a closed bracket. So in a roster form, we represent the elements of a set in a bracket and each member is separated by a comma. So that is roster form. Then in set builder form, so set builder notation is a notation for describing a set by indicating the properties that its members must satisfy. Okay, in set builder form, so this is another representation. It's a roster form and set builder form are the two representations of a set. In set builder form, we represent the elements of a set in a detailed language or with a description what is actually mean by a set members of the set or the nature of a set in a detailed version. So then we more familiar when if we have the examples or we study the examples of these two forms. Then we can quickly go to the examples. Okay, so examples. So mainly, okay. So one point is mainly we define a set in some ways, either in a roster form or a set builder form, and we take the letter or used to represent a set is by capital letters, a capital A or capital B or capital C. So what is a roster form? So roster form listing elements of a set inside a bracket. So what is this roster form and set builder form? Suppose we have a set S, then we have to write what is the set S or what is the members of the set S. Okay? Then, so in a roster form, we so anyway the letters used to represent a set are mainly the capital letters A, B, C, D, E, etc. And in the set builder form, we have members of the set in a bracket, and each member is separated by a comma. Okay. So this is capital A is equal to, yeah, we start a bracket A, comma E, comma I, comma U, O, U. So A, E, I, U, U. So that are the letters in the set A or the members in the set A. So elements in the set A. So this is a set A. So A is a set. It has contain English letters A, E, I, O, U. So this set has 5 elements. So this is a 5 element set containing 5 letters, right? 5 English letters. So capital B is another set. So it is a set of English letters, and it is first 5 alphabets. It is the first 5 alphabets. So B is equal to set A, smaller, sorry, A, B, C, D, E. So this is the first 5 alphabets in the English language. So B is equal to A, B, C, D, E. So this representation, A is equal to A, E, I, U, U, B is equal to A, B, C, D, E in brackets. This notation is called the representation of the set in the roster form. Okay. So another way is capital A. So this A and this B is the representation of a set in a set builder form. So in a set builder form means we are defining a set in a detailed way, right? In a detailed way. So we read this set A as A is equal to set of all X. This bar we read as such that, this bar we read as such that X such that X is an even positive integer. X is an even positive integer. Then B is equal to it's another set. B is equal to set of all X such that X is an odd positive integer. X is an odd positive integer. So what we study now? So we already have the definition of a set. So definition of a set is it's a collection of well-defined. Yeah, it's a collection. That collection is on well-defined and it has distinct objects. Sorry, or a set is a well-defined collection of distinct objects. And we have we study the representation of a set in 2 forms. One is roster form and another is set builder form. In roster form, we notate or we write a set as in brackets and each member separated by a comma. And in set builder form, we write a set in a detailed way, right? In a detailed way. Okay.